Hi there, this is the third video, moving on to solving trigonometric equations. So bear in mind that I'm not going to use the cast method, I'm just going to draw something. So where we want to solve theta is a half between that interval. First thing I would do is always draw, oh dear, very badly, the graph. Try and make your curves kind of flatter rather than so. Don't do this because you've got such a small space. Try and make it wider so that you can see what you're writing and where your lines are coming from. So this is supposed to be +1 and this is supposed to be -1. So anything that's in between that, I then just draw a line right through the middle so that it gives me as much space as possible. So this I'm saying is a half, which in this case it is. So I want that value and that value because that lies between my 180 here and my 360 there. Whenever I'm drawing graphs, whatever graph it is, I only put in the 180 and 360s. I don't do 90 and 270s. So it just means that because the cosine graph is the kind of complete opposite, and where the tan graph goes through the axes, it's 180 and 360. So here I know this is what I'm looking for. So I get my graph, my calculator, do inverse sine of 0.5 and I get the answer 30, which gives one of those angles. I should know that. So sine to the -1 of a half gives me the answer 30. And from either those rules or looking at the graph, if I know that's 30, it means that this distance here is 30. So I can do 180 minus that distance. So I have these two answers, 30 and 150. For 5 tan theta equals 10, I then know that tan theta equals 10 over 5, which is 2. So then I need to draw my graph. So my first one goes up through here, and then I do my asymptotes either side. Now if I can try and get my asymptotes the same, then I can draw the same size graph in here. Okay, this one seems to there it is, good. Okay, get a different colour pen and 2. So this is my x and y axes. So 2 is anywhere along here, we don't really mind. It's between, so this is 0, this is -180, this is +180. So I only want it between those values because that's what it stresses here. So I'm looking for this one, this one, and then this one's too far out because 180 is there. So if I then do inverse tan of 2, I get an answer of, so inverse tan of 2, I get an answer of 63.43 degrees. So this one here is 63.43. So that means that air length there is 63.43. So I'm going to do -180 plus 63.43. And ideally they want the answers to 3 significant figures. To do more than that until they tell you, until you know what your final answer is, because now I've got 0.56, which will make that go up to 6, which it would do only if I'd done 4 there, but it's just to make sure because we will be doing other things to it. So I have 2 answers, my 63 and my 111 minus. Hopefully that's what will be here. 2. Lovely, to 1 decimal point, so they're doing this, so that's good. Okay, next one, slightly harder. Generally, I mean this in fact looks pretty much the same, but it's a minus, but it's still sine, so I'm going to still draw it. I'm still going to draw it here, nice and wide as I can. I'm still going to do the same thing. Now it's minus, that's 0, that's +1, remember, and -1 down here. So my -1/2 has got to be here somewhere. So I want this value and this value. So now this is up to you. You can either put in sine of a half or sine of minus a half. So if you do inverse sine of minus a half, oops, I do that right. You get the answer minus 30. So sine to the minus 1 of minus a half, you get the answer minus 30. So looking at my graph, I don't have a minus 30 on there because this is 0, that's 180, and this is 360. So I would have to do my graph the other side, which obviously blah blah blah. So this is the value of minus 30 I'm getting, which means this length here is the minus 30. So if I put in plus a half, it would have given me the same kind of thing, just through to symmetry of the shape. But you can put in minus a half, it'll give you the closest one to 0, that's what happens. So we know this length is 30, actual 30. So I know that if I go from there to there, I'm going to have to do 180 plus 30. And if I go from 360 back this way, that still little length is the same as crossing the 0, that little length. So it's 360 minus 30. So I still should come out with my 210 degrees here and my 330 degrees here. And the easiest way to check that is to put in your calculator sine of 210, what do I get? Minus a half. Sine of 330, what do I get? Minus a half. These questions are so easy to check, it's brilliant. Now this one, again, stepping up slightly more. We have two identities here, two trig functions, so we can't solve it like that. So thinking about the identities we have one that has sine divided by cos. So if I divide both sides by cos theta, that will cancel to 1, and I end up with sine over cos, which actually is tan theta, which is what we wanted, equals root 3. So then we have to, it's between 0 and 360. So again, do a little sketch. That's the positive, so we're going to go, I always start in the middle, like I say, do my attempt at asymptotes, do the same as you go along, keeping them similar distance, and then draw the next funny shapes in. So this is 0, which means that's 180, and this is 360, so I'm going up to that distance. I've got a positive value, so I'm just going to put a line in the positive side. I'm going to call that root 3, so I want this value, and that will be too big, so I don't need this value at the moment. So if I do inverse tan root 3, my answer I get is 60 degrees, which I should know. So tan to the minus 1 of root 3 is 60 degrees. So I now know that this length here is getting up to 60 there, which means it's the same as that one, even though my diagram's rubbish, and would have been the same for this one. So I have got 60 as my first one, and 180 plus 60 is my second one here. So that gives me 240. Again, check it by putting it in, so you could do sine of 60, does it equal cos of 60 times root 3? And does sine of 240 equal cos of 240 times root 3? Quick and easy way to do it, so that you make sure you get your answers. Again, given this is in video and you want to have a look at these signs, you can pause them obviously, just to check that what we're doing is correct. Okay, see if I can get another one done before these get, yeah, this is the last one of this one. So, right, so now we've got 2 cos theta, so we're still only on this, so you solve till you have cos theta, and again this should be an angle that we recognise. Oh, that's my email going mad. Here we go. Again, so now we need to draw a cos graph. Cos graph always starts up here. You're going between 0 and 360. And when I draw a cos graph, I always like to go dot, 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 180, dot, 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 360. Like I say, I only put in 0, 180 and 360. So we've got a positive value, so again, just go straight through the middle of all the positives. This is now root 3 over 2. and I want this value and this value that lie between my 0 and 360. So if I do shift cos of root 3 divided by 2, oops, root 3 divided by 2, I get 30, which I should have known, like you say. So my initial angle is 30 degrees, which means this shape here, it looks much more on my diagram, but remember that's 90, but this is 30, we reckon, which means going from the 360, which is exactly the same point, the dot dot dot, going backwards, because you need to have the symmetry. So this is the same shape, and obviously if it carried on that way, you could go 30 that way. But from the 0 outwards would be from the 0 that way. So this shape, my scribble distance necessarily, is also 30. So that's 360 minus 30. So I've got 330 as my other angle. Okay, final one again. We've got sine and cos. We can't solve something if there's two different ones and it isn't a quadratic or anything, or it's not factorized. So the only way I can solve this now is divide by cos again. So I'm going to do that now. So that becomes 1 because you divide it to the bottom. This becomes sine. So I've got tan theta is 1. So tan theta equals 1 over root 3. Again, that should be one we recognise. Again, like I said, I struggle to remember them. So tan, so I'm going to draw my first little curve, then put in my asymptotes, and then leave an extra one here and an extra one here, given the size we've got available, what they're looking for. This is 0, this is 180, this is minus 180. It's a positive line, a positive value, so I'm just going to draw a line across in the positives. This is my 1 over root 3. So the values I'm looking to read off of the x-axis is that one, because that's the y-axis, that one, and this one's too far gone. So that distance will be the first one I get out. So it's $30 again. So this is 30. This angle area is 32. So my first one is 30, and my second one is minus 50. Be minus 180 plus 30. So I've got those two. Okay. Seeing somebody do it should hopefully make it easier for you. And these are the more straightforward, but we'll be using more of the nastier questions next time. So 10D is the exercise you want to have a look at. Really all you've got is solving them, and then obviously some tan ones there. And then they like to do these where people have gone wrong. They're really worthwhile doing. So have a look at those questions. Make sure you have a look at the harder questions, and we will be looking at harder equations in the next video.